Yes, we can.
All right, so I'm gonna start. So, hi everyone. My name is Afaz Munshi, and I'll be giving you a quick introduction about R and RStudio today, and also we're going to be solving an assignment. Um, to give you a gist about R, right? So, first of all, what is R? R is a programming language, and RStudio is an IDE. So, we use RStudio to write R code in it. R is basically a tool for statistical analysis and data analysis, right? Um, Let me just open up RStudio. So it is very easy to download RStudio and R in your computer. You just search it on Google, R or RStudio, and you'd be able to download it for Mac, Windows, and Linux as well. Um, okay, so this is RStudio opened up right here. As you can see, this window on top left, this is scripting window. This is where you would write your code. This down here is your console. This right here is called environment. You can see all the variables that you're using in your current script mentioned right here. And this window right here, the bottom right corner, this is for looking at graphs and packages, etc. We'll see it later. So uh, let's start with basic commands. Um, this is console. You can do simple calculations like 2 plus 3 and you enter, it's 5. 10 divided by 2, enter, it's 5, right? So you can do simple commands over here. Um, so let me begin by telling you what is a vector. A vector is collection of data of same type. So it is a data structure, and we'll be storing data. So this is like, let me give you an example, right? Right. So as you can see, I have stored five numbers. I'm sorry. I've stored five numbers in the variable v. This is how you assign values. This arrow right here, less than, and a dash sign. This is an arrow. This is an assignment operator used in R. This is how you assign values. And this right here on the left side, left hand side, this is called an object. And this right here on right hand side, this is something called vector. I've made a vector. This C right here, this is concatenation, symbol for concatenation, or you can call it combination. So I'm mixing all these number 1, 2, 3, 4, and 5. I'm making an, you can think of it as an array or one dimensional matrix, if you will. I enter it, and if I type V, I get the vector 1, 2, 3, 4, 5. We'll be storing our data in same manner. All right. So let's jump onto the assignment. Um, just a little. So here we are given an assignment. We are asked to go to this website right here, which is, uh, if you open up this website, you'll end up being on a page like this, and you're asked to search for these city names, and then, for example, if I type New York, USA, I can get data about New York. I can get data about its education. Um, for example, I want to get data about its crime. Let's say combined crime. I can get. I just click on this little box, and I can get data about New York's crime rate. So I'm asked to collect uh, these five things: population, data about population, median income, poverty, status, crime, and education. These five things. So for example, I want to get data about population. I would go to, I believe, demographics and just click on population. What else am I? Median income. Median income. Poverty status. Uh, Poverty status below poverty. Okay. It is somewhere right here. You can find it. Actually, you can just tick all these check boxes and you'll get data over here. After, so what you have to do is go and click all of these, look for all of these terms, click all the check boxes required, click on the per capita and download the data. This way you can download a .csv file.
হ্যাঁ হ্যাঁ
You'll get
ওইটাই
a
আমরাও
file.
এই আসি যে যদি এরকম হয়
Um,
ইন্ডিয়ার থেকে দেখি এখন তো ইন্ডিয়ারও যে অবস্থা আমাদেরও তো সেই অবস্থা
so this way you'll be able to download data in a .csv format. So you'll end up downloading something like this. If you try to open this file, it would open up in Excel. This is a .csv format, comma separated values. Now you can save this file in a folder, and we are going to be using this data to perform further operations using RStudio. All right, back to the assignment. Here are the instructions given here, how to download the data, everything I've just said. So let's go further. The first thing we are asked to do is reading the data. How do we read data from a .csv file into R? So to perform operations on the data, first we have to load data into the RStudio, and then after we can perform any operation we want. So first we are asked to download the .csv file, which would be named as export.csv. We already have it. The next step we are asked to do is library tidyverse. So let me show you what this is. Library tidyverse. Now tidyverse is a package name that is, so package is a bunch of code already written for you so that you can use it to perform complicated tasks very easily. You do not have to write a lot of code because the code is already written for you and inside this package called tidyverse. So you have to first of all install this package. How do you do that? You go here on the bottom right corner tab, you go to packages, you go to install, and you write tidyverse. Yeah, tidyverse, and you just install it. Now this is already this is already installed in my system, so I'm not going to install it. But once you click install, it will do some processing in here in the console window, and it would be then after you can use it. I already have tidyverse. Now tidyverse is basically a package used for data science stuff. Um, so once you have installed tidyverse, you'll write this line of code, that is library tidyverse. This is to load that package. You have installed the package. The next step is to load the package into the system. So what you would do is just write library tidyverse. In order to use any package, you write this line of code, library, and then name of the package, right? Now, once you have done that, um, the next step is to import the .csv file that we have just downloaded. But before doing that, make sure to check your current working directory. So what happens is when you ask for this export.csv file, your RStudio by default will search for this file in your working directory. And if it doesn't find this file over there, then it wouldn't run or throw an error. So it is important to install this in your working directory. or change your working directory to where this file is already installed. How do I know what is my working directory? Well, it's very simple. Just write get wd, just write this and you'll get a path. So this is my current working directory, this desktop slash R project. Your might be different. It can probably be in user slash documents or anything of that sort. But if you want to change your working directory to a particular folder, there's a way to do it. Go to the sessions and set working directory and then choose a directory of your choice. So you can choose the directory where you have stored this .csv file, right? Um, once you have done that, the next step is to load that file, get the data from that .csv file and keep it in an object, right? So as I mentioned before, to assign a value, we use this less than dash sign or an arrow. This is assignment operator. So data is our object. I'm assigning data to this object. To read a CSV file, we have a function called read underscore CSV and the name of the file, right? So it will take all the content from .csv file, export.csv file that we have downloaded and put it in the data object. Now we have all the content of data object. If I want to see what is in currently in my data object, I would just write data, D-A-T-A, control enter. And as you can see here, this is my whole CSV file right here. So this whole content is stored in my data object. All the instructions are already given in the assignment, but I'll still explain. Right. In order to clear the console, there's a shortcut key, Control L, and it will clear up the console. Also, to run any command on this window right here, you just take your cursor to that line and press Control Enter, and it will run that command. For example, your data. If I want to see what my data object has, I would just click Control Enter. It will show it on my console. Now, next step. Now, once we have gotten the data from our .csv file, we are asked to clean the data, right? Because this is a mess up. We need to clean the data. We need to arrange data in order to work on it properly, right? So what we would do is we create 5 different objects. We are working on 5 different cities. As you can see here, we are asked to download data for 5 different cities. We would create 5 different objects like data, take uh, take data from the data object or the .csv file. For example, I want to take data for the LA, that is Los Angeles. In this assignment, it has already given that on column number 1, 2, 4, 5, and 22, there exists data for Los Angeles. So what do I mean? So this is our .csv file in Excel. On column number 1, 2, 5, and 22, all these columns, this is the data for Los Angeles. This is the data for Los Angeles. For Miami, column number 1, 6, 8, 9, and 23. So 1, column number 6 is this, 8, 9, and 23. These are the data for Miami. This is date is the common column, so we are using it in all of these cities. But so we want to store data for different cities in different objects, right? So first I'll create an object LA, assignment operator, take data from LA. Now this is a space that I've written nothing here and then comma. This means select all the rows. If I write nothing and just write a comma, this means select all the rows. Select all the rows from 1 to 31. These are the rows, right? from 1 to 31. Select all the rows and from column number 1, column number 2, 5, and 22. Select all the rows, combine column number 1, 2, 4, 5, and 22. So I've gotten the data for LA. Now I must give names to those data. For example, here is some vague name given to it. Criminal activities combined. So I want to change this name. So the way to do this is giving name to that object, assignment operator. Now this order matters. So this is corresponding to all these columns. So year for column number 1, crime for column number 2, poverty for column number 4, and so forth. Now next step is that I am adding a new column called city and giving it the name LA because name of the city is LA. Let's see how it looks like. So my cursor is on LA, control enter. As you can see, I got data from 1990 to 2019, all the columns. So I've chosen 5 columns. So 1, 2, 3, 4, 5, and then I added the city afterwards. So that this is the 6th column. Right? This is a way to add a new column at the end of the data. Similarly, we'll do it for all the other cities, Miami, Chicago, NYC, Austin, right? Okay, so we have 5 different data objects for 5 different cities. Now we want to combine all these objects, separated objects, and I'm going to do it by rbind operator. What is this rbind? I'm sorry, not rbind operator. Rbind command. Rbind combines all the rows. For example, this is my data for Miami. I'm sorry, LA. Now data for Miami will look something like this as well. Now what I will do is get the data for Miami and put it under this after line 30. Then after I'll take data from Chicago and put it under the Miami, then New York and Austin. So it is combining the data row wise. First LA, then underneath it Miami, Chicago, NYC, and Austin. So as you can see here, we have 30 rows. After combining data for 5 cities, we would have 150 rows because 30 times 5 is 150. So we've got LA. I have to run all of this command. So control enter. Oh, all right. So now I'll run the command to bind all the data, and to print the data, I'll just write the word data. That's just name of the object, right? And we got 140 more rows. These are 10 rows and more 140. So in total, there are 150 rows. Now, once we have done that, we are asked the next step. In the next step, we are asked to filter out the data. So as you can see, there are data from 1990s to 2019, right? So apparently we do not need that much data. We only need data from 2012 to 2019, right? So it's the subset of the data, the whole data. And we'll be working on data just from 2012 to 2019. So how do we do that? So I'm going to create a new object, data subset. Now in R, you can actually use dot here while naming a variable or naming an object. This is not an object oriented thing. So do not get confused. If you know Java or C++, you might get confused because you can use dot operator with an object, but it is not true. This is just a name, data subset. assignment operator, and then I can use a filter function. Filter function, what it does is whatever is, I must give it two parameters. So in the first parameter, I'm saying it take whatever is in data object that we created here, take whatever is in data object, and this is a Boolean, uh, I'm sorry, this is an if condition. So only take data from the data object if the year column, we have given this as a name as year, its name is year, if its value is greater than or equal to 2000 and less than or equal to 2019. So between 2012 and 19, and put it in the data subset object, right? Next, I want to see what is inside my data subset. So we have this command head, and then I give it data subset. This means show me first 6 lines of data subset. Head means show me first 6 lines of data subset. Tail means show me last 6 lines of data subset. So let me run this line. It is successfully run. Look at the first 6 lines. As you can see, there are only 6 lines. I've gotten, so this starts from 2012. And if I want to see last 6 lines, starts from 2014 to 2019. So we have successfully filtered out the data from 2012 to through 2019. And in the assignment as well, you can see the expected output here. If you run these commands, head data subset, tail data subset, you should expect this, and that's what we got, right? Next is a select function. So uh, yeah, so what I want to do here is yeah, what I want to do here is, so as you can see in this table, there is an year column. Now I do not need year anymore. So I want to remove this column. How do I do that? That's pretty simple. Just use this function, select dataset minus year. This means what, take the data from dataset and remove the year from it. Remove the year column from it. Minus year means remove the year column. So if you run this line, there is no year in it, right? And I want to reassign this value to data subset, right? So data subset equals to data subset minus the year column. This is something like that, right? So I must run this line. If I run data subset, and as you can see, the year column is removed. The next thing I'm asked to do is to rearrange the columns. Um, so as you can see, it starts with crime, poverty, education, income, and city. What I want is to have the city name first, and then crime afterwards, income afterwards, and so forth. So what I did here is reassign data subset as data subset, the square bracket, nothing but comma. This means select all the rows from the data subset and then combine these uh, four variables: city, crime, income, poverty, and education in this order. So take, so reassign all the values to data subset basically, right? So reassign the city column, and then after crime column, and then after income column, and so forth to the data subset. So first the data subset look like this: crime, poverty, education. If I run this command and then data subset again, the city has come first: city, crime, income, poverty, education, etc. And if you want to check if this, there are 30 more rows, so we cannot check the whole data set. So what we usually do is just check the head and the tail, which is fine. This is same as the expected output here, right? Now, next we are asked to mutate um, using the mutate function. So using the mutate function, we are asked to round all the values to five significant, I'm sorry, 5 digits after the decimal point. What does this mean? So we have values like 0.0456 and so on. So let's say I have a value 0.123456. What I want to do is round down that value to 0.12345 and not 6. Only 5 digits are allowed after the decimal point. So how do I do that? So again, I'm reassigning the data to the variable data subset. Again, as a reminder, data subset is our data from year 2012 to 2019 that we filtered previously. Um, so mutating goes like this: take data from data subset and around, uh, I'm sorry, yeah, okay, so I've added a new thing here. So I made an object here, all columns. What I'm doing here is selecting all the columns first, right? Except for city, right? Because I am performing this operation on a number. City has a string, LA or Austin or NYC, etc. So I do not want to include the city column. I just want to include the crime, income, poverty, and education column. So what I do, as I mentioned before, we can use the select function to exclude the city column. So I just write minus city from data subset. And if I run this command, um, as you can see, city is gone. This is a new object that I've created, a temporary object, you can say. Now what I'm doing is mutating this function. Um, Mutating is basically, you can say, you take a database, I'm sorry, you take data and you can perform a function on that data, on the whole data. So round is basically a function in rounding a value. So what I'm doing here, round takes two parameters, the data and digits, up to which you want to um, round the values to. Also, one thing I forgot to mention is that if you're confused about any function or how it works, you can just type it here in the console for help. So you just write question mark, round and round. So if I have confusion about round, I don't know what round is, or I want to know more about round, I just write round question mark. And as you can see on the bottom right window, there's a description for rounding numbers. So it shows that how you can use it. As you can see, there's a round function here. X is the data and digits is how many digits you want to round the number to after the decimal place. So I was asked to round only 5 digits. Um, and here are all the columns that I've selected. Remember, I filtered out the city. So I've not included the city. If you do not do this, it will give you an error because city does not have numbers, right? We are working with numbers. So rounding all the numbers from this data and storing it into the subset, data subset, right? And I run this command and run data subset. I've got the city here. Remember, I did not exclude city from the data subset. I made a temporary object and excluded city from there. And then I worked on that data and then stored it in the data subset object, right? So I have this, they are all rounded to 5 digits. So yeah, you can see head and tail. These are the output and you can match your output with these expected output. They should be safe, right? Um, so that's about it with cleaning the data. Now, so we had a messed up data right here in form of comma separated values. We have cleaned the data. We have sorted by the name of the city, and now we have data in a good order. So next thing we're going to do is visualization. We're going to visualize the data. Basically, we're going to create graphs. Now remember, all these functions, mutate or select or filter, these are the inbuilt functions from the tidyverse package that we initially installed. So if you do not install this package, you wouldn't be able to use these functions, right? So, so yes, that package gives you all the functionalities. So next is about plotting. So box plot. Now this, uh, I'm sorry, with data visualization is very simple. It's very easy in R. It would be really hard, but R makes it very easy for us. So we have all the data, and using that data, I just want to make a box plot. You might have heard about box plot in your statistics class. They teach it in statistics. I'm not going to go uh, in theory about box plot, but I'm going to show how to implement a box plot in the R. All right, so for data visualization, we use something called ggplot. This is a very this is ggplot is also a package, and you would have to install ggplot. However, because we installed tidyverse, it tidyverse already includes ggplot, so we do not have to do it again. Um, so you can just right away use ggplot. So what we can do is ask for help. What is ggplot? Gg console, and as we can see, ggplot, it takes various parameters, it takes arguments uh, to create a graph. So as you will see, ggplot, it takes various arguments here. So data set, it takes the whole data set in here. What is the data you're going to be working on? And it takes something called aesthetics, AES. Um, and the first parameter is the x-axis. So I'm going to give, as you can see, I have data for city. This is my data subset data set, and then I have a column for city. I have a column for city right here. So I'm going to give city and crime. I also have data for crime. It takes this from the data subset. I'm going to explain this fill equals to city later, but once you do this, you have to add. This is not adding, but this is a plus sign. This means you are using a box plot. You write the word genome, sorry, geom, geom underscore box plot. And yeah, you do not have to write this. This is the width of the box and width of the line width. So let me just run the program and we'll see. All right, so we got a box plot, a graph or box plot right here on the right window, bottom right window. And we can click on this zoom button in order to see the whole graph, take a look at the graph. So as you can see, this is a box plot for Austin, Chicago, LA, Miami, and New York. And this is crime on the y-axis, and this is city on the x-axis, as I mentioned before. Now, this fill equals to city. With this, now this fills up color to the boxes. So if I just remove this and try to run the program, Control Enter, it will give me simple looking box plots. But if I write this command, it will automatically fill color to different box plots according to the name of the city. Different colors for different cities, right? Control Z. And this is just for the width of these lines right here, right? Control enter again and get this. This is similar to this chart right here that we are expected to make a create. Yeah, so this is about box plot. Now you also asked this question, do you see any patterns worth noting? But this goes deep into statistics. You must know a few statistics concepts. Uh, but yeah, let's move on to the next graph, that is histogram. Histogram, you all know it looks something like this. We ought to create something like this. And histogram, guess what? Histogram has these almost similar code. It also uses ggplot. As I mentioned before, ggplot is the easier way to create graphs or visualize data. ggplot, it takes the parameter data subset. Where should it get its data from? Then it takes aesthetics. Now, as you can see, there's only one parameter, x-axis, crime, because we're asked to take crime as our data. So it takes only one parameter. Histogram will always take only one parameter, that is crime, and then it will count the frequency or the count of the crime. So these are the only two parameters you need for a histogram. And then you write geom histogram. Before we wrote geom box plot. Now in this case you have to write geom um, histogram. Now this you can fill up the color. So it's so as you can see this is a red histogram. So I also chose the color red, and then this is LWD is line width, and black is the, I believe it's the border color of the border. If I run this command, you get a histogram. You can zoom in, and you can see your histogram is created. As you can see, crime, and this is the count of frequency of the histogram. This is similar to the data that we were expected to create. That is this. Now let's move on to other data, other type of graph, that is scatter plot. So we're asked to create a scatter plot between crime versus poverty, right? So scatter plot, in case you're thinking, it looks something like this. How do we create this? Well, again, similar procedure, ggplot, data subset, where is it taking the data from? Aesthetics, poverty versus crime, right? So as you can see, there's poverty here on x-axis, crime on the y-axis, poverty versus crime. And in this case, we write geom underscore point. This is to create a scatter plot graph. Color equals to green. That means these little circles will be of green color, and size of these circles is equal to 3. You can change the size. I zoom the graph. You can see uh, is exactly as we were expected to create, right? So as you have seen how easy it is to create or visualize data and graphs using RStudio and R programming language. Otherwise, in real life, it would be really complicated or difficult. But R makes it easier for us, especially because of these packages, ggplot. So yeah, that was the main part. Now next we are asked to do some statistical tests. Now there's something called ANOVA test, and it has, let me show you. So it has some kind of formula. I'm not sure how this goes, but the way to do an ANOVA test is just write AOV and then write independent variable first, I believe. Crime is the independent. Okay, so dependent variable first and independent variable afterwards. This tilde symbol means uh, you're writing the dependent variable here from the data subset. And then you just write the summary of ANOVA. So you know what a summary is, right? Uh, Summary of all the statistical calculation. Let me show you. So if I write this command, I've stored it in the ANOVA object, and next summary. We got the summary of the data. So these are all kind of technical terms for statistics. So I couldn't really explain this, but this is the way you would do an ANOVA test. And this is the result we were expected to create, and we got the result, right? Next is regression, linear regression. Um, so linear regression, I kind of know what linear regression is. So this is, if this is the kind of data, then a straight line should pass through this data such that the distance between these points and that line is as minimum as possible. It helps to predict data. Is what linear regression is. And a formula for linear regression goes something like this: y equals to f of x. X is the variables given to a function plus error. This is the formula for linear regression. But in R, if you want to create a linear regression, um, you use this command lm. Um, so we're asked to create a linear regression. Uh, so as crime is a dependent variable and poverty as an independent variable. So independent variable means this x is a variable, right? This is independent, but y is dependent on x. So this crime is y and poverty is independent x. But yeah, so this is very simple to create a linear regression. Just write the command lm and variable, name of the variables, dependent tilde independent, and from what data set are you taking it from, right? And I've stored it in an object called lmove. This is an assignment operator, right? If I just run this command, control enter, and ask for the summary, I'll get this whole summary about this data. Um, all the p-values and data frame, f statistics, etc. Right, so this is the expected output, and this is what you should get. This is not a big deal. This is a very straightforward thing. This is how you would calculate a linear regression: dependent variable, independent variable, and the data set you're taking it from. And then furthermore, you're asked to calculate data set, I'm sorry, linear regression, uh, making poverty and education as independent variable and keeping crime as dependent variable. So how you do that? Taking two variables means just add a plus sign in between poverty and education from data set. Crime as dependent variable. You run this command, summary it, and you get the summary, right? Then you're asked for poverty and income, and finally you ask for poverty, income, and education. Summary for this. Summary for this. This is your expected output, and you're asked to analyze from that data. So imagine this would take a lot of calculation, a lot of time if you're you know doing it manually, but using this computer technology R and RStudio, it becomes really easy for you. Just one line of code and you're done, right? So that was it about the assignment. That is how you, the basic introduction as to how you use certain commands in R. And Yeah, so remember all the commands that we use, all the functionalities that we use comes from this tidyverse package. You must install this package first before uh, doing anything, right? So do you guys have any questions? Yeah.
I got a little bit confused with the inputting the data part. I got a little bit lost there, and I was wondering if you could
Uh-huh. Inputting the right here. You're talking about this, like exporting the data from CSV file, right?
Yes.
Okay. So our file is in the .csv format, right? Comma separated values. So what we want to do is run this command, read underscore CSV, and put it in the object called data. So think of it as a variable. We call it object in R, but this is actually a variable. We take the .csv file. So this file is in .csv format. We take data from this comma separated values, all the data from it, and put it in the data object, right? And how do we do that? Using read underscore CSV, uh, using this command. This comes from the tidyverse package, so it becomes easier for you to read the CSV file, right? So yeah, so this is basically exporting your CSV data to a variable, and then we clean up this data. Once we have the data, all the data in our system, we kind of clean the data, right? So we separate the data for LA city, and Miami city, Chicago city, etc. And then we combine all the cleaned data together. Then we next step is to filter the data from year 2012 to 2019. Yeah, this is how we do it. And in case you're confused about reading the data, there's no big deal because they have mentioned how to do this here, using under read underscore CSV. And yeah, yeah. Aditya, please.
So the problem I'm having is when I try to run the data read CSV, that part, like the second line, it says that it's not in my working directory. So like, do I just need to move it to a different file on my computer, or?
Yeah, so as I mentioned previously, what you ought to do is first check out what is your working directory. What is your current working directory? Probably it is not going to be the working directory where you have stored the file. So to do that, what to see what is your current working directory, just type getwd, that is on your console, and you'll get an address, a location of what is your current working directory, right? And then what you want to do is go to this session up here and go to set working directory, choose a directory, and choose the directory where you have saved that .csv file, and then you'd be able to run, because your R would look for the file inside your working directory.
Thank you.
Right. Angel, please.
After downloading the tidyverse through packages, how do you library it and then import the data?
Oh yeah, so you just write the command library tidyverse, right? And then just type, just press Control Enter or Command Enter in Mac, and you'll be able to do so. So first step is to install the tidyverse, and then library. Library, it means just write this line of code, library and name of the package. And for importing the data, you do this via read underscore CSV command, and you give the name of the file. Make sure you are in the right working directory, or your file is saved in correct working directory. So in case, just as a reminder, how to install the tidyverse package. This is a very important part. So either you can write packages.install and then name of the packages, or you can simply go here on the bottom right window and go to sorry, packages, go to packages, press the install button, write the name of the directory, tidyverse, just press the install, and it says I already have it. So I'm not going to do that, but then after I will install, and then you write this command library tidyverse, and then you import the data, right? Also, just as a reminder, this when we are separating the data, this means we are selecting all the rows, right? I could have written rows from 1 to 10, and it would have, so this means select rows from 1 through 10. This would have mean that only select rows from 1 to 10. Let me show you. From row number 1 to 10, and all the columns that I have mentioned, that is 1, 2, 5, 22, 8, right? But what I want to do is select all the rows. So instead of writing from 1 through 31, I just write comma, just comma, and R would understand that you want everything. Any other questions? Yes, please. Sumaya.
I have a question. How do you do the arrow for the coding?
Yeah, you just so if you're on a Windows keyboard, just less than sign and then the dash sign, minus sign. That is the arrow.
Okay.
Yeah.
Okay, thank you.
No problem. A less than minus C 1, 2, 3, right? The vector collection of data. Yes, Philip.
I just have a question. If you were to download it on like an older Mac, for like downloading it on an older Mac, do you know what the latest, like the oldest RStudio is? Because what I see online is it can only go up to like the Mac OS High Sierra, and anything below it like can't be supported. So do you know if there's anything older than that version for RStudio?
I'm not sure about that, but if for you can search that on internet, of course, but if in any case you are not able to run your or download your the RStudio on your computer or R on your computer, you can also use the online version of R. You can use it on your any of your browsers. You can just write RStudio online, and you would be able to write code on your browser. You would be able to use the RStudio on browser. I haven't used it in a long time, but let me see. I'm not sure if you have to pay for this or RStudio probably where the university account actually. But yeah, you can try to log in and see if it works on the online version. But I'm sorry, I'm not sure about the downloading process on Mac. What is the latest version? Yeah. Yes, Angel.
It says that the system can't find the export.csv file.
Okay. So once again, type the getwd, that means get working directory, on the console and press enter, and you'll see a location of your current working directory. So if your working directory or if your file is not stored in that location, then it wouldn't work. So option one is that you take your file and store it in this folder, Or you can do is go to session, set working directory, choose a directory, and then you can choose whatever directory you want to work in, or whichever directory your file is saved in, right?
Okay, thank you.
Yeah, no problem. Katrina, go ahead.
So when we finish the code, how do we like submit it to the assignment? Are we able to export the code into a file? And if so, can you show us how?
So I do not know how to submit the assignment. I have only solved the assignment, but so what you're going to get is this kind of file that is test, not test, this is the name of the file I've given, but this kind of file that is .r format. This file is in .r format. You'd get this kind of file. So perhaps you can submit, they would be expecting this file. I don't think you'd be expecting anything else or in any other format.
Okay, wait, I have like one other question on top of that. So when we submit it, do we submit just our code, or do we have to like somehow show the outputs we got and how they match the ones on the document?
You know what? You just have to submit your code. Just have to submit your code. So whenever your marker will open up the file, you'd run the code and they can see your output, right?
Okay.
It is the
Got it.
code that matters. Yeah.
Thank you.
Yeah,
No
at the
problem.
end, there's a conclusion part, I believe. So for that, in that case, for everyone else who is doing the assignment, just write up a conclusion. Yeah. It can just be like 2 sentences after you just make this output, and that's it.
Aditya, yeah, go ahead.
So for when I ran the code for the histogram, it says something about picking a better value with bin width.
Yes. So you can ignore this because on the assignment as well, in the expected output, you can see this line. You'll be getting this error message. So this is a part of your output. Yes. So that is okay.
Okay, thank you.
Sia, yes.
Sorry. So I know you have to submit like the graphs and the conclusion, but for the code, do you like how would exactly would I submit that? Would I just like copy it into?
No. All right. So once you write your code or once you write a script here in the RStudio and you save your code will be saved in a file called .r. So my name of my file is newtest.r. I've given it that name, newtest.r. Now it is saved in this location right here. You will get something like this. You'll be able to save this file. And whenever I open this file, so let's say I have this other file called test. If I just click this file and open, it will open up in RStudio.